Hi class. So sorry I couldn't be here today, but what we are going to be doing today is we're still going to be going to prepare for our lab exam, and we're going to do it with me there virtually. So today's preparation of the lab exam is going to be going over our separating mixtures. So again, just like I said in class multiple times, it's based on all of the labs that we've done so far. So separating mixtures using sedimentation, decantation, filtration, and distillation. So we're going to be going through each of the steps. We're going to be going through again what's a mixture, what types of mixtures we have, and what are the techniques that you can use. So let's get started. So our overview. The first thing that's important to note is when is the lab exam? So our lab exam is going to be on Tuesday, December 17th. So very, very, very important date to know. And this is again a day 6. You know about this, but again, write it down. What is going to be on the lab exam? Separating heterogeneous mixtures. So again, mixtures where I can see the two different components. Separating homogeneous mixtures. And because this is a lab exam, we obviously are going to have components of a lab report. So just take a time to write this down, and then we're going to be going over the next slide. Okay, so mixtures. By definition, a mixture is made up of 2 or more different types of particles that are not chemically bounded. This is really, really important because if they're chemically bounded, you don't have a mixture, you actually have a pure substance. Mixtures can be separated. So if I'm putting 2 substances together and I can take them apart and I did not undergo a chemical reaction, this is a mixture. And we have 2 types of mixtures. Again, the types of mixtures that I can see the components, being a heterogeneous mixture, and the types of mixtures where I cannot see the components, and that would be a homogeneous mixture. So if I'm looking at this diagram over here, sand plus water gives me a heterogeneous mixture because look, I can see the sand, right? The sand sunk down to the bottom of this picture, and the water, because it is less dense than the sand, is on the top, making it a heterogeneous mixture. Now if I'm looking at the bottom, sugar and water, right? We have sugar, which is, again, a pure substance. I have water, which, again, in this case, is going to be a pure substance because all I have are those 2 components. When I put them together, I have a homogeneous mixture because guess what? Can I see the sugar particles? No. Does it look like what I had before in my container of just water? Yes, and that's the key thing about it being a homogeneous mixture. Homogeneous, the prefix homo means one. So a homogeneous mixture is a mixture where I only see one state. And in this case, my state that I would be seeing would be my water. Hetero, the prefix hetero means 2. So whenever I have a heterogeneous mixture, I can see 2 or more of my components. And I can actually see it very easily here. I have my water, which is my liquid component, component number 1. And I have my sand, which is my solid component, component number 2. So what we're going to be doing is we're going to be going into a little bit more detail of what a heterogeneous mixture is and what a homogeneous mixture is. So we have our heterogeneous mixture. And the key thing about our heterogeneous mixture is that our particles are not equally spread out. And because they are not equally spread out, I can actually see my different particles with my eyes. And the key thing about this is I see 2 or more phases. And when I'm talking about phases, I mean states of matter. Remember, first term, we talked about our states of matter. I have 3 on Earth. I have 3 solid, liquid, and gas. So when I'm talking about my phases, I can either see, in this case, how many phases do I see? And you're all jumping up, raising your hand. Well, if you're said that you can see 2 phases, you're right. I can see my solid phase, which would be my tea leaves, and I can see a liquid phase, which would be water. Now, if I'm looking at my next animation, which the video kind of cuts, but you can still see behind it, how many different phases do I see here? I also see 2. But in this case, my phases are both liquids. So I actually see 2 liquids here. In this case, right over here, my liquids are non-soluble, right? Because they're not mixing. And non-soluble means that they do not dissolve in one another. So for any of my heterogeneous mixtures, I only really have 2 techniques here. I have decantation or filtration. Now, out of the 2, which one would I be using which technique? Well, for this one right here, I'd actually be using decantation, and I would probably use the decantating funnel that we did in the lab demo with Miss Melanie. Here, because I have a solid and a liquid, and I need to actually produce a physical barrier because I can see my tea leaves are not actually falling to the bottom, I would need to be using filtration here. So we're now going to look at our other type of mixture, which is a homogeneous mixture. Now, in our homogeneous mixture, we have the particles that are equally spread out. And the key thing about a homogeneous mixture is that it looks like a pure substance. I cannot tell visually that I have multiple components there. So if I'm looking at here, I have my sugar and water. Can I tell that there's sugar in there? No, I can't, right? And the only way that I'd be able to tell or figure out that it's a homogeneous mixture, now you can't do this in the lab, but if I had this at home, I drank it. And what would it taste like? It would taste sweet. And that's the only reason why I would be able to tell just from using my senses that this is a homogeneous mixture. But because I can't, I would have to use one of my separation techniques. Key thing about homogeneous mixture, I only see one phase. It just looks like a pure substance, so I'm not going to be seeing multiple phases. And the only technique that I can use here is distillation, because distillation works on using the boiling point of one of the 2 substances in the mixture. Now, because most of the mixtures that we use, actually all of the mixtures that we've used in class are made in water, the boiling point that we're going to be using for this technique would be the boiling point of water, which is exactly 100 degrees Celsius. So what we're going to be doing is we're going to be looking at the different separation techniques, how they are, and how to do that. Because guess what? You're going to have to do this by yourself next week. All right. Our first separation technique is decantation, and it is, again, for heterogeneous mixtures. Now, if we can see right here, I have 2 examples of heterogeneous mixtures. In this case, I have one that has 2 phases, a solid phase and a liquid phase, so sand and water. And I'm just going to write that. Sand plus water. And here I have, again, 2 phases, but this case they're both liquid, and it's oil and water. So with decantation, again, used for non-soluble liquids and mixtures where the solid is extremely dense and it sinks. Now, to decant, by definition, means to pour. So when you're using decantation, you are pouring one of the layers out. And the key thing that you actually have to do here is you actually have to let the layers settle. So you're really doing sedimentation for a few minutes before you decant. So the procedure, pour the top layer of the mixture into another container. Oh, let's just erase this because it's in the way. And that's the key thing. You actually have to have layers forming here. So, and what you're doing is you're just removing the top layer and you're pouring it into another container. So if we look at the next slide, we actually see this happening. So we have our mixture with our residue, and then we have our decant. So what gets left over, that solid part in my original container, that's going to be my residue. And the component that I removed from my mixture. So what I'm being pouring out is actually called the decant. So it's what I have decanted out of my mixture. Our next separation technique is filtration. So usually filtration, I mean, you can do it instead of decantation, but it also depends on the mixture. So if we had, I don't know, a mixture of water and black pepper, it doesn't matter how long you leave the water and the black pepper on the table, the black pepper particles are not going to sink. They're very, very light, around approximately the same density and a little bit lighter than the density of water, so they're never going to sink. So you would have to use filtration here. A situation that you can use filtration after decantation would be the classic, I have a mixture of sand and water, right? I can, decant the water out of my container, but then I have still some sand particles there, and I'm like, I don't want to have sand particles in my mixture, so then I would have to use filtration. So with filtration, again, most of the time you use it for anything that has light particles, but sometimes you can use it where you have heavier particles. But the thing that you actually have to be really careful here is that they're not to the point where they're too heavy and they actually rip the filter paper. Because if they rip your filter paper, well, then you actually haven't filtered anything. You just actually have your substance remixing again. So, and this is actually another thing with filter paper. You actually have different varieties of filter paper depending on what you're doing. So you can have very, very thin filter paper for extremely light particles, and you can actually have thicker filter paper for heavier particles. So like the filter paper that we used in class is actually quite thick. All of you probably have filter paper at home. Coffee filter. It's actually much thinner because coffee grinds are actually usually very, very small. So again, with filter paper, you have different varieties of filter paper. Now, the procedure, place the filter paper into the funnel. Now, you don't just place it, you have to fold it. And the way that you fold it is very specific. So I'm just going to take a piece of filter paper and I'll actually show you how to do that. Okay, so what I have right here is a piece of coffee filter paper. So what I did is I actually cut it in the shape of the filter paper that you'll actually have in the class. So to fold this, the first thing I need to do, just like probably what Miss Melanie said, is make the taco. So I'm taking this and I'm folding this into a half semicircle. It's a little difficult with only one functioning hand. Okay, so now I have this. So now what I'm going to do this is I'm actually going to make a quarter circle. So I'm going to fold it into a quarter. Now you have a use, so what you want to do to make sure that your edges are quite sharp, you want to kind of like use like a ruler or a flat edge to straighten them out. So I don't have a ruler, but I have a pair of scissors, so I'm just gonna, can you see? There we go. So see this right here, I have this, and I'm just sharpening out the flats and sharpening out the flats. Okay, so now what I have, and then what you're going to do is you're going to pick up 3 of the pieces. So you have, look on the side and the front view, it's going to look like this. So I have like a funnel, it's going to look like this, and then I will actually put this inside my funnel. So put this in my funnel, and then I have my filter paper like this. So again, how did I do this? Circle, fold in half once, fold in half again, and then I'm going to pick 3 of the layers, and then I have, there you go. Now hopefully none of you will have broken your elbow before your lab exam, and you will be able to do this without much difficulty. Okay, here we go. I'm back. So have your filter paper, and then once you actually have your filter paper in your funnel, simply pour the mixture into the funnel. Now, when you're pouring, again, you don't pour all of it in at one shot. You actually have to pour a little bit time and time again until all of your mixture goes through the filter paper. Okay, so if I'm looking right here, I have my mixture of whatever. In this case, it's sand and water. Have my filter paper with my funnel. And then I am going to pour my mixture, and what I have is my residue gets stuck by the filter paper, and my filtrate is the liquid that goes through the filter paper. So again, my filter paper acts as that physical barrier to separate my residue from my filtrate. So we actually have that here again. What goes through the filter is my filtrate. What is stopped by the filter is the residue. So I'm just going to write that right here because I'm filtrate. And the residue. Okay, so we've talked about decantation, we've talked about filtration, and again, those are used for heterogeneous mixtures. Now, the only one that we can use for homogeneous mixtures is distillation. That's the only separation technique that works for homogeneous mixtures. So, homogeneous mixtures, distillation. Now, the key thing that we use for distillation is that it's based on the boiling point of one of our components. Now, because all of our mixtures are basically dissolved in water, so all of the mixtures that we have, whether they're homogeneous or heterogeneous, are based on mixtures that are water-based. We're basically going to be boiling water. And the key thing that we need to remember is that water on planet Earth, and yes, we are all on planet Earth, boils at 100 degrees Celsius. So that means, yes, we're going to be using lots of equipment here. We're going to be using a hot plate. We're going to be using a retort stand. We're going to be using our Florence flask. We're going to be using a condenser. We're going to be using test tubes. And yes, you need to know all of those equipment. Yes, you need to know how to spell them. Now, again, if you're on the lab exam and you know the equipment and you're like, oh my gosh, I do not remember how to spell Florence flask, you can raise your hand and either myself or Miss Melanie or anybody else in the room will come and you can say, how do I spell Florence flask? And we'll be able to tell you. But if you just point to the lab equipment and be like, how do I spell this? I'm not going to be able to tell you. You have to tell me the name of the lab equipment and then I will tell you how to spell it. Doesn't go the other way around. So going back to distillation. So again, it's the only one that works for a homogeneous solution. Now, because we are boiling one of our substances, this case water, we actually have two phase changes. So we have evaporation, where I go from liquid to a gas, and then I have condensation, where I take the gas that I have just made, and because I am boiling water, that gas is water vapor, and I cool it, and it turns into a liquid. And that's really, really important here because with distillation, I am using the phase change to separate one of the components. So what's actually really common, one of the ways that they use actually distillation is in removing caffeine from different substances. They'll actually, if you're making a cup of coffee and you actually want to see how much caffeine was in your cup of coffee, you would take your coffee and you would undergo distillation. So you would boil the water out of the coffee and then the powder that remains would actually be the caffeine that was in the coffee. So I'm using that to basically remove my liquid component because again, with my homogeneous solution, I actually have my solute that's dissolved in the spaces between my solvent. So again, my solute, the small component, what is being dissolved, the solvent, the component they have more of what is doing the dissolving. And because all of our mixtures that we've been talking about in class are water-based mixtures, my solvent is water. So our procedure. So my first thing that I need to do is I have to set up the distillation apparatus. So again, that's the retort stand, that's the Florence flask, that's clamping the Florence flask, the retort stand. We're going to go through it. Bring the mixture to a boil, kind of important because that's the only way that I can separate the two components. Trap the vapor, so trap my water vapor, and then cool my water vapor so my water vapor goes back into liquid form. So we're going to look at the setup. Oh, and again, this is my homogeneous mixture, and when I'm looking at it, my homogeneous mixture looks like a pure substance. So this is my setup. You need to know how to set up your distillation apparatus. We did it in class. We did a lab on it in class. You're going to have to be able to do this. Now, Miss Melly and I are not going to be setting it up for you, but we're going to be going around making sure that you're setting it up properly without, the obvious of breaking any of the equipment. Now, in class, we're not going to be using a Bunsen burner, but instead we're going to be using a hot plate. So you're not going to have this in class. It's just online. I couldn't find a picture that had a hot plate. So we're actually going to be using hot plate. Again, we have our mixture, we have our retort stand, we have our clamp, and we have our Florence flask that is clamped to the clamp. Now, just like in the picture that our Florence flask is on top of the flame but not touching the flame, it would be the same thing with our hot plate, that our Florence flask would be on top of the hot plate, extremely close to it, but not touching it. So again, like we said in class, if I can slide a piece of paper, so again, this isn't my filter paper, but if I can slide my piece of paper underneath my Florence flask and it can go through it easily, then I have enough space. So what you're really looking for is about the space that I have in between my two fingers, which is about ½ centimeter. So if you have a ½ centimeter gap between your Florence flask and your hot plate, then you know you actually have the right distance. The reason why you want it as close as possible is because you want to have that heat exchange. If the gap is too big, it's going to take longer to boil. If the flask is on the hot plate, well, then you can get the situation where the glass might explode, which is not what we want to have in class. So that's why we actually have a little bit of space in between. So we have our condenser, and the whole purpose of our condenser is for our liquid to undergo condensation. So our condenser is going to be cooling our vapor that produces here. So if we're looking at our setup, evaporation takes place here. It is my liquid underneath the heat source. What happens to liquid when you put enough heat? It will eventually undergo evaporation. So I have my steam, steam going through the condenser, and it's cooling down, and condensation takes place here because it is cooling down. Now, those are my two phase changes. During my distillation apparatus, again, just like in my filtration, just like in decantation, when I separate my mixture, I get two components. In distillation, I have the residue. So the residue is the solid component that gets left in my Florence flask. So that is the component that does not undergo my phase changes. What does undergo my phase change is called the distillate. So, hold on. You cannot see this. Hold on, let me just pause. Okay, so we have our distillate that forms here. So our distillate is the substance that undergoes distillation. So the substance that evaporates and then condenses. So in this case, that is going to be water. So distillation, again, for homogeneous solution. What goes through the phase changes is called your distillate. What remains in your Florence flask is called your residue. So if we're looking at our terminology, our residue is the leftovers from decantation, from filtration, and from distillation. So the thing that gets left over is the residue. And the thing that's pretty easy, it's all the residue. There's only two terms that you actually need to know. Well, three terms. The leftovers from, the component that undergoes distillation is called the distillate. The component that goes through the filter paper is called the filtrate. The component that you decant, so that you pour out, is called the decant. So again, this is terminology that we've used in class, and this is terminology that you need to know for the lab exam. Components of a lab report. This is a lab exam. That means you are writing a lab report, which we've done a lot of in class. So the first thing is you have your hypothesis, which is their if-then statements. Now, again, we've been doing a lot of hypotheses in class, and one of the things with our hypothesis is that it is not a guess. It is going to be based on what you're doing in the experiment. So your hypothesis is kind of more like a guideline in the sense of, if you do X, Y, and Z, I am going to have this result. Now, because you are separating mixtures, and because you are separating homogeneous mixtures and heterogeneous mixtures, you actually need to have not one statement, but a statement per mixture you are separating. So if I only give you one mixture, you would be giving me one statement. If I'm giving you two mixtures, so let's say I'm giving you one homogeneous mixture and one heterogeneous mixture, well, you need to give me an if-then statement for the heterogeneous mixture. You need to give me an if-then statement for the homogeneous mixture, because the procedures that you're going to be using are going to be different. So an example of, and this is what I was saying, should be specific to each mixture and how I'm separating it. So, okay, let's say I was separating in mixtures of different sized rocks, which is not on the lab exam. It's one of the separation techniques that we saw in the lab with Miss Melanie. So I would write my hypothesis based on that. So if I use the technique of sieving, then I would be able to separate my heterogeneous mixture of different sized rocks. It's not a guess. It is an if-then statement, because if I do this procedure, then I'll be able to get that result. So it fits my hypothesis statement, and it's the guideline of what I need to be doing. And that's what we've been talking about when we've been working about hypotheses. So again, one statement for a heterogeneous mixture, one statement for a homogeneous mixture. So here we have an example of a really good hypothesis. And again, this is not one that is on this exam. This is actually the hypothesis that you needed for the term 1 lab exam when we were doing density. So if we're looking at this, if you obtain the mass and volume of the object using a balance in water displacement and divide the two values, then you will obtain its density. The reason why this works as a hypothesis is because I have my if-then structure, number one. Number two, I'm clearly spelling out exactly what you have to do. So if I were to get the mass and volume and divide them, I will be able to calculate the density. And not only am I saying getting those two values, but how I'm doing it. Now, that was needed for something like this. Because of this lab exam, it would be sufficient to say using the technique of sedimentation, or using the technique of decantation, or using the technique of filtration, or using the technique of distillation, because that is a technique, that is the process to do your task. So that's the key thing with a hypothesis. You do need to be able to do this. And we've been doing a lot of practice on hypotheses. Look at your old labs. See how the setup is. Look at your labs on sedimentation, decantation, filtration, and distillation. We actually have a fill-in-the-blank hypotheses. Look at those. to help you with what you would need to do for the lab exam. The next part of the component of the lab report, materials, material list. It's all the time. This is something that we do all the time. You've done this multiple times. You know how to do this. It's a specific list of equipment and specify the size. I don't want to see one beaker. Okay, what size beaker? Am I talking about a 10 milliliter beaker that's this big? Or am I talking about like a 4-liter beaker that's like this big? Specify. So, and the key thing with all of the glassware, it has the measurements. So if I have a 250 milliliter beaker, it's going to say 250 milliliters, right? I look for the biggest increment. If I'm using a 10 milliliter graduated cylinder, tell me 10 milliliter graduated cylinder. If I'm using a Florence flask that has a volume of 500 milliliters, 500 milliliter Florence flask. So you need to specify the size of the lab equipment, and it needs to be written as a list. So I'm writing a list form, not a paragraph. You know, there's places for paragraphs somewhere else, but in a material list, I'm writing it as a list form. So this is basically everything that you need to do for the lab exam. I highly suggest that you study the notes that we've taken now, study your notes that you have on mixtures. On the class website, there's actually videos of every single separation technique. So there's a video on decantation, there's a video on filtration, there's a video on distillation. Watch them, right? Watch that, go through our notes, look through the workbook, because everything that you need for the lab exam, you also need for your term test, which is the class after the lab exam, okay? You're all going to be good. You're all going to be fully prepared for this. You need to make sure that you're studying, all right? So if you have any questions, you know where to find me, my office, send me an email. Make sure that you are reading through your notes, reading through the workbook, going on the class website for extra help, and you will be fine. All right, see you guys later.